process state diagram. So every process has state will be there only state. Every process now state now. For example, whenever you create a new process, how to create a new process? Run a dot out. Create a new process. Whenever you create a new process in the command line or graphically whatever, okay. Once you create a new process, the process first to enter the new state only. New state. First enter the new state only. In the process management point of view, the first beginning state only. So once enter the new state, nothing but now the process now ready to execute actually. So but how ready to run process? The process need some kind of the resources actually. Process need resources. Resources nothing but peripherals and memory. Generally, IO and memory. Our process you want execution time also some sufficient amount of memory required. Okay, code section, data section, and the peripherals also. The process need to communicate the basic peripheral like a keyboard or monitor, and maybe depends on the peripheral installation. Okay, so process what is the peripheral expectation? Those resources are available. Okay, sufficient amount of memory. What are the peripherals to communicate? Those are active. Then only process enter to the ready state only. Ready. Okay, sufficient process whatever the required sufficient IO and memory is available. Then process move to the ready state only. Ready state. Once the process enter the ready state, now process try to execution now. Now start. Now only pending execution only. So, but how to execute the process? Now the one is ready state. Now process in the memory. So process divide into different sections. Okay. Yeah, code section, data section, stack section. Process divided into section. See, code section, data section, stack section. There three sections are there on the process. So now these all the sections are one center of the memory. So the only part execution only. When execution, program counter point out the program and start execution. Program counter microprocessor to load the execution. So the job who do process management on that. So because what happened actually in the ready the state, so many processes are on the line actually. Okay, P1, okay, P2, okay, P3, so many on the line actually because not only one process, we are maintaining some line queue. Okay, it's called ready queue. In the queue, in the line actually, ready queue. In the queue line on now. Because user can run multiple programs now. P1, P2, P3, all are the maintain the queue now. The ready queue. Ready that you are maintaining queue now. Okay, how many number of programs running? Queue only. So open the task manager. So many programs are running on task manager in Windows now. Or run the PS command. You can see all the running process in the Linux. So, but actually only one process can allocate. Depending on the multi-core architecture, in case of dual core architecture is there, 2 process, quad core, 4 like that, whatever. Maybe my assumption uniprocessor, single processor is there. One processor, it can execute only one program at a time. Cannot execute more than that. Here so many are there now. So now we need to assign a process to processor. Okay. Dispatch a process to the processor. That is called running state. So running. We call it dispatch. Dispatch. So the process dispatching here to here actually. The job who done, we need algorithm actually. They're called sub-zero algorithm actually. So in the market, so many algorithms are available. The very basic algorithm, FIFO algorithm. First in, first out algorithm. Sub-zero algorithm only. First in, first out algorithm. First algorithm. So the algorithm responsibility assign a process to processor. A processor is there on this. Processor execution. Okay. Assign a process to processor. Nothing but moving the process from ready to here only. Okay. Algorithm responsibility like a FIFO. What is FIFO? First in, first out. In the line, 3 numbers are there. Who first enter? P1. P1 dispatch. P1 delete the ready queue. Remove the ready queue. Assign to the processor. Now P1 here. Okay. FIFO algorithm. FIFO. First in, first out algorithm. Enter here. So now P1 running right now. P1 terminating after some time actually. P1 running and after some time terminating also. terminating. Okay, after some time the life is over. P1 come to a terminating also. Life is over. Terminating. So next right now processor ideal only, microprocessor ideal state. Other than next one who P2. P2 remove from the ready queue, assign to the P2 here only. Any new process coming, attach here only. Any new P3, P4, whatever, yeah, new. Any new one is coming in the line maintenance also. Queue. Meanwhile, the P2 running on now. So P2 also some life is over, terminating. Like that, the cycle running only. What happen here? If you, for example, any process is waiting some IO event. For example, in the P2 process, in the line number 10, in the P2 program, line number 10, invoke the scanf on the scanf. Scanf the read on read. The meaning of scanf, process 2 waiting for IO event. Scanf is waiting for IO event. Whenever waiting for IO event, but the process is not running. Because whenever it's pressing the keyboard, then only can active. So whenever you can scan up nothing, but the process not running actually. It's a waiting state moving now. Waiting. So IO event occurs. So whenever IO event occurs, process moving from running state to waiting state. Waiting. Because scan up best example. Scan up. So in future you can check it now. Like a sensor data you want to read, but device not ready. You want to wait some time. Okay, maybe the time is 100 milliseconds, or maybe the unknown time also. You want wait here, waiting now. The P2 move to here action. Here wait also one more queue is here only. Device wait queue. So many processes are waiting on for the device action. Device not ready, they are waiting. So many programs are waiting. Here adding the wait queue. Wait queue adding. So scheduling algorithm what happened? Tell me. P2 moving here only. The algorithm now assigned to next P3 only. Because right now nobody is there actually. Because P2 come to here. The microprocessor nobody is there. Okay. So algorithm assigned into P3. So you have the microprocessor here. It can execute one instruction at a time. But which program run? Algorithm decide. Algorithm scheduler algorithm decide. FIFO algorithm one by one assigning also. But the process terminated, new one coming. Our process moved to waiting also, new one coming. Nobody is coming now. You are waiting P2, some amount of time, data available, device ready, IO event completion. You are waiting for the scanf actually. Scanf the data. After some time, the data is available only. Then it is again back to the ready queue. Now in the end of the queue, again happen now. Now right now nobody is there. Your P2 coming again. But actually your P3 running only. P3 running only. So after P3 completed, okay, then only again next to P2 come out. Okay. So like that, the FIFO, every algorithm have some rules only. According to the rule, can system running only. The FIFO rule is what? First come, first service. Whoever first enter, assigning only. But running time, the process terminating, or running time, the process move to waiting, the program logic decide. The program logic. Line number 10, terminating, over, live. Line number 10, waiting, waiting. The program decide, the program sequence now. First come, first service disadvantage. First one taken like a 100 millisecond time only. Second program execution time is a 10 millisecond only. What happened here? What do you mean by first come service? First one take a 100 millisecond time. Second one wait for completion of the first one only.
Second one.
Millisecond only. Small amount of time.
Second one.
Necessarily waiting for 100 millisecond only. So that's why first come first service algorithm is a smallest job, smallest process, long waiting time. Starvation, long waiting time. Smallest job. Okay, smallest job pays a starvation, long waiting time. This is a disadvantage of first come first service algorithm only. First come first service algorithm not recommended. So second algorithm we can take it. Shortest job first algorithm. Shortest job first algorithm. Okay. For example, what is shortest job first algorithm? You can see P1, P2 in the queue. In the queue, 3 processes will be there in the queue now. P1, P2, P3, Q are there. In the linked list like that. 3 are there. Okay. Three are there in that line. 3 are line only. P1 time taken 50 millisecond. P2 time taken 20 millisecond. P1 time, P3 time taken 10 millisecond. The time actually. The P1 program small, 50 millisecond program. Okay, maybe 100 lines are there. Here 50 lines are there. Small program. P1 is a P3 very small, 5 lines only. So your program very small actually compared to P1, P2. So now in the ready queue, 3 processes are there in the ready queue right now. Okay, P1 is a very lengthy. Okay, if you go supermarket now, the supermarket queue is there only. So first person bring the so many items only. Second one is a average. Third one is a very less amount of items only. Okay, so what happened? Tell me shortage job first. The 3 members line only. So now we can accept the only shortage job first. Okay, so who the shortage job first here? Who here? P3. The shortage job first is there. Which is the shortest one? We need to accept all. Which is the shortest one here?
P3.
P3 shortest one.
Sure.
P3 is shortest one. Shortest you can expect now. You can expect. So because remaining is the longest one. According to algorithm, shortest one. Now who assigned the process? Tell me. Who assigned? Which one? Which was an assignment? P3. Correct or not?
Yes, sir. P3.
Which algorithm? SJF. P3. So remaining 2 processes are in the queue now. In the queue. They are not running on it. So the shortage of first algorithm assigned to the least one. Least process can assign also. Least one can assign. It's the least process taken. Next to P3 life is over. Next to which one assigning?
P2.
P2 assigning. Like that. Okay. First one is a what FCFS now? First come first service only. In case of first one first service algorithm, FIFO no? Yeah, called FCFS algorithm. Okay.
Yes, sir. FIFO.
Yeah, FCFS algorithm. So in the first come first service algorithm, P1 assigning action.
Yes, sir. P1 assign.
Okay. So here is what happened. Which is a smaller one? Smaller one first. Okay, but not a first person. Okay, smaller one. But in the shortage of first also drawback is there only. Yeah, the drawback is there. What drawback? For example, no, the P1 50 millisecond. Okay, P3 10 millisecond or P2 20 millisecond. Okay, first priority. Okay, over. P1 waiting for 10 plus 20 millisecond, 30 millisecond waiting on. Fine, okay. So before P1 enter, one more is coming actually. Like a P4 is coming also. So new one coming that moment. Within the 30 millisecond delay, one more process enter. The process delay is a 20 millisecond again, like 50 millisecond only. So obviously you are also lesser than this one only. Again, algorithm gives a preference to P4 one now. The P1 what happened? Longest waiting only. Because so many people, the process are coming. Everyone is the smallest job compared to the first one only. So first one is waiting. So longest wait. Sometimes infinite time also wait also. Indefinite time waiting also. Okay. Because small process only give the first priority only. Smallest. So in the SJF algorithm, advantage throughput mode. Throughput. More number of process run actually. Throughput mode. Throughput nothing but you can execute more number of tasks for time. So within the time period, more tasks can execute now because so many small coming. The output is a more. Okay, longest one keep on waiting only, but small process will complete that. Okay, small. So many are there. You can complete one by one. Okay. Disadvantage is longest process waiting one. Longest waiting. Keep on. That is that one. Longest process waiting. We are the SJF algorithm advantage and disadvantage. So one more algorithm is there only. So priority algorithm. Priority. P1 is a process. P2 is a process. P3 is a process. Priority is there only. Priority. So priority important here. 3 on the line only. P3 is a priority number here 2, your priority number 5, your priority number 8. Priority number factor. So the priority number lesser is a high priority. Lesser is a high priority. Which is high priority here?
P3 sir 2.
P3 high priority. So now what happened? Earlier what happened? Job time verification. Now third one. What third algorithm? Priority algorithm. So every process assign a priority now. Okay. So the P1 is a normal common man only. Okay. Is average man P2. P3 is a VIP person. Okay. Whenever three people in the line, but P3 is the last only. But P2 VIP person now. Stop the P2 P1. Okay. First P1 enter actually, but no chance because common normal man only. P2 average. Okay. Wait. P3 then come to late only, but highest priority is the VIP person. Whenever VIP coming, stop all the people and then give the permission to P3 one. So now P3 get the priority. So P3 assigning one. First P3 assigning one. P3 job is over, then P2 start only. Like then build the priority. So in the ready queue, process assigning moment, in the ready queue, how many number of process in the queue, which is the highest priority, that one allocate the process. So what is the problem here also? Okay, slowest priority, least priority. Least priority is the longest time on. Common man always waiting one. VIP person coming, waiting longest time on. So the priority algorithm. Third one on priority. In the priority algorithm, one more concept also there. Okay. So first P1 running, P2 are there. Two processes are there only. Here the 5, here 8 only. Two are there. Okay. In the priority also, two types are there. Preemptive priority, non-preemptive priority. Okay. I'm telling preemptive priority. Check it now. Preemptive priority. What is preemptive priority? Check it now. Preemptive. So the meaning of preemptive priority algorithm. So write down the queue. People observe now. Queue only two are there. So highest priority P2. So definitely the algorithm assigned to P2 only. P2 running only. But P2 job is my assumption P2 time is 50 millisecond. P2 time is 50 millisecond on the. Out of 50 millisecond, P2 time period 50 millisecond time period. Okay. Out of 50 millisecond, so 10th millisecond, 10th. The price of P2 running here, P2 job 50 millisecond. The 50 running, because why P2 running? P2 high priority, because number 5 compared to P1 high priority assigning only. Okay, that's why. But 50 millisecond time only. So 10th millisecond running, with 10 millisecond completed only. 40 millisecond pending only. P2 currently running the 10th millisecond. That moment, new process enter, that new is a P3 enter option. P3 enter. But P3 is a priority 2. Priority number 2 only. But right now who running? P2 running only. P2 running in the 10th millisecond, 40 millisecond pending. 40 millisecond pending. Okay, exact 10th millisecond the running moment. New one running action. New one enter. That moment. New one is what? VIP person. Right now common man start running. Okay. But that moment VIP coming only. So you enter and start communication, execution. Okay. Common. Okay. Common process. Okay. No, normal. Okay. That time VIP coming only. So whenever VIP is coming, so already 40 millisecond pending only. So the meaning of priority, running process less low priority compared to the coming the new process. Now stop the P2. Now stop the P2. That is preemption. The meaning of preemption, stop the low priority process, stop the P2. P2 again back to the ready queue, stop it now. P2 again back to the ready queue. We call preemption. Preemption happen only. This is called preemption only. The meaning of preemption, running process forcibly stop back to the here. Again P2 back here only. P2 back here only. Now P3 assigning also. P3 dispatching also. They call it preemptive priority algorithm. Preemptive. So the meaning of preemption. So whenever the process running is a least priority running moment, suddenly high priority process coming, stop the least one, give a chance to high priority only. Wherever the position, stop it now, wherever that moment. 40 millisecond pending is there, but we are stopping assigning also. We call it preemptive priority algorithm. One more algorithm also there only, non-preemptive. Non-preemptive. priority algorithm also there only. So no preemption. I mean, not available. Is not available. No preemption. The 50 millisecond completion, then one is coming. Non-preemptive. Priority always in the whenever the assign time, check the priority. So algorithm in the queue, how many are there? Which is a priority? That moment assigning one. That's a priority. But preemption, non-preemption, depending on the two models are there. Okay. Yeah. Fourth one is there. One more. Fourth algorithm. Fourth time sharing algorithm only. They are round robin generally. Why the round robin algorithm? A round method, like a three processes will be there. All are equally assigned some time only. Time sharing algorithm. Okay. Everyone equal time only. P1 run 10 milliseconds, stop. P2 run 10 milliseconds, stop. P3 run 10 milliseconds, stop. Again start P1 onwards. Time sharing algorithm. So because of time sharing, what happens? Everyone progress is there only. Okay. In the line, 3 members are there. P1 10 millisecond time spending. Then P1 wait. Next to P2 10 millisecond time. Next to P3 10 millisecond time. Again round. So what happens? Everything progress will be there. So in my system, I open so many processes now, so many applications. Okay. So all the processes are running to the time saving mode. And all are the programs running only. As a user, I'm see every program output only. Everything output coming. Okay. Because everything as a user, I'm expecting everyone should run. Okay. Every program should run on now. Okay. Definitely. Okay. So that's why you can go to the round robin algorithm. Is a time saving algorithm only. The time is a depend on the internal algorithm assigned 10 millisecond delay or 5 something assigning also. Okay, like that. So you also preemptive is there. Yeah, preemptive only round robin preemptive algorithm only. Okay. So here is a 50 millisecond. Here 20 millisecond. Here 10 millisecond. Okay. What happened? The time slice is a start also. Okay. Here is a, for example, 30 millisecond. Here is a 20 millisecond. Time slice start also. Time slice is a 10 millisecond only. Assumption 10 millisecond. So first P1 assigning only. After 10 millisecond preemption. Preemption only. Preemption only. The P1 after 10 millisecond preemption again back also. So because the P1 actual 50 millisecond, 10 millisecond is over, then 40 millisecond is there. Again back only. Next P2 assigning off. P2 running, P2 30 millisecond, 10 millisecond is over, again back also. Like 20 millisecond pending on. Next P3 running only, 10 millisecond, next 10 millisecond pending only. Next start P1 onward. P1 next 10 millisecond running, 30 millisecond on. P2 10 millisecond 10 pending only. Next P3 terminating also, 10 only terminating on. Next like that. Okay, round robin. In middleware, someone enter, okay, automatically you also join the loop on. Okay, like that the process only, round robin. So round robin is a better compared to remaining algorithms only. So the time slice properly can allocate because everyone should be in the progress mode, running mode. Okay, it's always better to run.
So in Linux, what is the scheduling algorithm they have used it?
So in the Linux, you are using to the CFS algorithm. So CFS is a completely fair scheduler algorithm. The 2.6.23 in the kernel is releasing actually. Okay, in the kernel some flags are there. The flag indicates then the CFS algorithm. So the CFS algorithm is working with the algorithm internally red block tree concept. Okay, the red block tree concept. So this is a red block tree technology. The way the algorithm, the algorithm concept. Okay. So overall the purpose is the same. Okay, the main intention is a time sharing only. So in the process state diagram, process any state now, either new state, ready state, running state, terminate state, or waiting state only. This state also called a blocking state also, blocking also, sleeping also. 3 names actually. What is sleeping? For example, you can programmer invoke the sleep 10. Then process moving from running to sleeping only 10 seconds. sleeping purpose program. Okay, waiting, blocking. Okay, anything happen in the programmer come to this state only. You are waiting. Okay, pause not running now. You are waiting or sleeping or blocking. Whenever it's completed, again back here, ready queue. Then, so the scheduling algorithm only dispatch a process to processor, ready queue, whatever available, those only dispatching only to the processor. So, okay, whatever I told, everything single core processor, maybe multi-core processor is a SMP algorithm, symmetric multi-processor algorithms are there, SMP. So, dual core, quad core, so many processors are there. So, that algorithm follow. So, equal distributing on it. SMP equal distribution. Every processor equal responsibility. So, multi-core processor advantage, throughput more. Throughput more. That's why everyone multi-core interesting now. So, n number of process increasing, you can run more number of tasks, more. Okay, executing. So, get the response.